will you start and you will describe the general concept, and then I can add, you know, some details on like different pollutants and what exactly we measure and what maybe our strategies or approaches are. Does that make sense?
Sure. Yeah, absolutely.
Yes. Well, thank you, Ellie and Marcel. I'd like to have both of you introduce yourselves. Give us a little bit of your background too, and a little bit of background of this interesting group within Mann and Hummel and how it all evolved, and then we'll pursue the application of this technology for the coronavirus. So Ellie, why don't you introduce yourself?
Sure, absolutely. Hi, everyone. My name is Ellie Amirnasr, and I've been with Mann Hummel for about 7 years now. I actually graduated from NC State, North Carolina State University, with PhD in fiber and polymer science, mainly focusing on filtration efficiency and filter material development. And as soon as I graduated, I joined Mann Hummel as innovation project manager, and later on in my career, after 4 years, together with Marcel and some other colleagues, we co-founded qlAir about 2 years ago, which we will talk about the solution moving forward. At this point, I'm leading the team. I am the CEO of qlAir, and mainly focusing on the business development side, where Marcel is helping with the product development and leading the development team on the other side.
Very good. And Marcel?
All right, so I'm with Mann Hummel actually a little bit longer than Ellie already. So I'm with the company since 9 years. Originally, I'm from Germany, as you might be able to hear. I started in the Mann Hummel headquarters 9 years ago in product management. My academia background is more mechanical engineering. So when I started with Mann Hummel, I worked in the automotive product management. I was first responsible for very automotive-like parts like intake manifolds, and then later took over a product group of cabin air filtration systems. That was the first time I came in contact with the topic of air quality and indoor air quality, cabin indoor air quality in passenger cars. And then, as Ellie described, end of 2017, we co-founded qlAir in California in context of an incubation program with the company Mann Hummel that we've already worked before. We decided to have this innovation speedboat qlAir a little bit outside of the corporate context and have a separate entity for that. And yeah, since then, since the beginning of 2018, I'm working mainly on the product development side, and also with our strategic partners. So we are working with a development team that is abroad, working with them in Europe, another team, or our team capabilities internally. We're mainly built around data science, so we have experts in that field. And yeah, that's what we did so far. Oh, one thing I forgot. I did my MBA at the University of Louisville and finished that last year. So mechanical engineering and MBA is my background.
I see. And I understand that you just conducted a webinar relating your activities with Clean Air as a Service to COVID. Maybe that might be a good starting point. What kind of conclusions or information were you providing in that webinar?
Sure. We basically first started with introducing ourselves and what qlAir is about actually, and why we are the right people to talk about the correlation between the air quality and the situation going right now with COVID-19. So I will start the same way, that saying who we are, what we do, and then the objective of the webinar that we had and the relevancy to the situation, if that's okay with you, Bob.
That sounds good.
Okay, so basically, I mean, if we put qlAir as a group of people or a team, we are a team of indoor air quality experts that are dedicated to creating intelligent air quality solution for addressing the most critical challenges facing facility management today. We're basically, our mission is to support and help the facility management industry to create a safe, clean, and efficient environment for their clients, tenants, customers, employees, whoever is coming inside their building. Well, our offers are coming with like leading edge monitoring solutions that is together with the hardware, as Marcel said, with like driving by the very strong data analytics to be able to deliver actionable insights for the building and help the facility manager to make informed decision, and also best-in-class services to remediate the indoor air quality issues by partnering up with companies that can support to improve the indoor air quality and indoor environment. So the objective of the webinar that we had, or basically what we are working these days around, it's around what air quality has. What is the contribution of air quality in COVID-19 situation? So the basic objective was to identify and understand the implications of poor indoor air quality and inefficient environmental control. And then we wanted to we are discovering the ways that indoor air quality applies to transmission and mortality rate of COVID-19, and then helping the customers, the facility managers, business owners to implement the right strategies available and help them ensure that their buildings are safe and clean to reopen. I'm sure you've heard of so many different news and articles, and everybody's coming with the new modes of transmissions, but then we categorize them basically in when you summarize what's coming from the news, it has been categorized in 3 main modes of transmission. One is contact transmission, which is touching the surface, like high-touch surfaces like tables, doorknobs, all of these, and to the prevention strategy for those is like really surface disinfection, proper cleaning, washing hands, and other recommendation regarding the cleaning and disinfection. The second way of transmission is respiratory transmission, which is basically direct. This way is actually through big droplets that the virus actually is contained in. When somebody coughs, speak, sing, shout, in an enclosed environment, and you're close to that person, and that you can basically inhale these big droplets in a very close contact. So the prevention strategies for those is really social distancing and personal protection equipments like face mask. And the last one, which these days, very recently, has been getting some more attention from WHO and from CDC as well, and a lot of scientists have been writing letters to these organizations as airborne transmission. That means that the virus can actually stick to microparticles or be in the micro droplets. And linger around in the air that you are breathing around you, and it can actually survive up to 30 minutes, and it can travel long distance. So it means that if somebody's passing by a hallway 20 minutes ago and is infected and coughed, it is chance if like 20 minutes later you pass that and the environment, it's not protected properly or it's not cleaned properly, you get infected. So this is the area that we discussed in our webinar of how you make sure that your environment is safe and protected from airborne transmission of this virus.
Yeah, I think those are all very good points. But before you even go on there, because I do want to emphasize how important all this is. Number one, some of the scientists are now believing just about 100% of the transmission is airborne. And if you think in terms of even say coughing into a mask, what happens when you cough into that mask or even cough onto the ground? Those cough droplets start to evaporate, and there's a lot of science now which shows all sorts of viral transmission even off of the floor as people walk along, and they're generating viruses back into the air. So it's very, I think, plain to think in terms of what you're doing to remove airborne transmission as basically being the key. And then the other factor that we've uncovered, just trying to keep up with all this research, is a lot of these viruses may become dormant after an hour or two in the air. But a lot of new research shows that these dormant particles, when they penetrate the lungs, are rejuvenated, and may become even the most dangerous particles. So this puts even more emphasis on what you're doing. But please continue.
Exactly.
Continue here.
Thank you. Yes, this is exactly what's basically the evolving research, and they're getting to know more and more about how this virus is getting transmitted, how long it actually survives, and what we are trying to do. I would like to put a disclaimer here. We're absolutely not medical doctors and professionals, but what we're trying to do is really to do our research and make sure we are up to date with that and provide right solution and right recommendation and insight for building manager as we are navigating through this situation altogether.
Very good point. Yeah.
Yep. Yeah, so it was really good point that you mentioned regarding the particles. I mean, I know that there is a lot of recommendations coming from, for example, or the information coming from WHO and CDC or other health organization about how this virus can be transmitted. Okay, as you mentioned some of those points as well. And then they are building organization, building standards who are putting guidelines and recommendation what to do and how to operate that. But there is a gap between these two, and that's the gap is like, why should we do any of these? You know, so you're telling me that it's airborne, and you're telling me that I have to increase my ventilation. But why is that? How is it going to help? So this is where we come into the play, and we first of all we kind of talk about what are the parameters related to the COVID-19. As you mentioned, one of the main ones is the fine dust or the particle that this virus can actually stick to. So there's been research from Harvard School of Public Health that talks about the correlation between the amount of particulate matter, 2.5 micron, and the mortality rate or the infection rate of COVID-19. And by looking at that research, you see that they are inhalable particles that can penetrate deep in the lungs, and the virus can actually, the exposure to this particle can increase the chance and risk of getting infected through these particles. And that's why there is a recommendation of putting advanced filtration system in place, for example, HEPA filtration, or also increasing the fresh air inside the building to make sure that they dilute the amount of particles inside the building. And you see that a lot of recommendation is coming to keep PM 2.5 or particulate matter 2.5 micron below 10 microgram per cubic meter. So you want to, I mean, this number is like kind of very arbitrary. It's just, you know, okay, what does 10 means? How do I know it's below 10 or not? And that's where we kind of come into play. And I always like to say that we make the invisible visible. You can't see those particles. You don't know what is the level of the particle in your building. You don't know if the solution that you're putting in place is working or not. So what we do by monitoring, first of all, identifying the critical areas and monitoring for the particulate matter level, and showing you what that level is in a real time and a continuous matter, you can definitely know that your system and solution is working better. You can make sure that your environment is safe. And that's what we call that clean as a service. That's where we go through that full circle that you're actually showing here. And in the sensor and monitoring, you're basically identifying the critical areas. We help you to identify the problems. And that sound and seems complicated, but it's actually a user-friendly solution that you don't have to do anything. Marcel and his team actually focusing on all these data analytics to just show you a simple way in the levels that you just need to know. You don't have to look at the complicated graphs. You don't have to make complicated decisions. This is where we actually come into play and tell you where exactly the problem is. And we provide you an insight on the mitigation solution. Either you have that solution already in your building, or if you need to find that solution, we'll help you to find that. If you need to, for example, increase the ventilation, we'll tell you exactly where in the building you need to increase the outdoor ventilation. If you require to have and like, you know, a portable HEPA filtration unit, or you need to change your filters, for example, to protect your indoor from outdoor air pollution, will help you find that as well. And then going through the full circle, we will show you with the continuous monitoring the solution effectiveness. So you have the peace of mind that the action that you took is actually helping and improving your indoor air quality, or it's not. You know, there's so many solutions out there we see with, like, you know, bipolar ionization, plasma, UV, and I'm not saying that none of them is working. I'm just saying that it will help you to understand which one of them is working and if it's working effectively for your application, you know, for the building that you have specifically, either be office space or hotel or a casino or a hospital. And then from here, you go full circle and you will be very alert about the areas that might come into the problem. There might be, like, you know, an area that all of a sudden has a source of pollution coming from inside. You know, something spilled, somebody is like cleaning, vacuuming, things are like the PM level is going high. You will get the alert and make sure that everything is going back to normal. If not, you will go to the full circle to find the right solution for that specific area. So this is kind of a solution that puts you ahead and not reacting to the problem that's rising, but mainly being proactive to keeping your building safe and clean.
That makes sense. So maybe just even skipping down just to highlight that to one of your studies, you know, here's a study that where the hospital ventilation was poor, and you were able to, in your analysis, show where the ventilation was bad. It was a chemical laboratory or something, and why the VOCs were high in that particular area, and solve the problem. So yeah, that's kind of the one very basic example, is it not?
Absolutely, yes. Marcel, you want to go ahead and talk about that?
No, I just wanted to, yeah, I think what differentiates us and our approach also from what we see in the market is really we have a really holistic view on the topic of air quality and air management inside the building. So, and I think this example from the hospital is a very good example on how we are approaching and how we are conducting our projects. And it is actually very similar to a problem related to air quality in regular times and now to the COVID-19 situation. So the first thing, and because we had a couple of problems actually that we needed to solve one after the other in this hospital. First of all, we just knew when we came in there, they have some kind of complaints. In some areas of the hospital, they did not really know where this pollution or this potential pollution, or is it only in smell, or is it harmful, where is it actually coming from? So what we are always doing when we're doing our projects, we're having a look at the outdoor air quality data for a specific location. We work with a data provider in that field. They mainly use public available measurement sources, for example, from the government or from the CDC or EPA. And then we can analyze in a first step, how is the outdoor air quality, what is coming to the ventilation system, how is it traveling through the ventilation system into the space. So we fairly fast realized this is a problem that is clearly coming from inside the hospital. And then we installed our sensors in different floors, and we could pinpoint after a few weeks of monitoring very precisely where the potential or where the pollution source is actually in the building, because we have the data and we know how is the pollution distributing and traveling through the building. So where does a pollutant peak start? In our case, we saw it's in the basement, then it travels to the first and second floor via the ventilation system. So we pinpointed a specific room in the basement of this hospital. We made a visual inspection, and it got very clear that there is leaking chemical containers in that room that are causing those high VOC readings in this case, and therefore also the complaints to formaldehyde smell in other floors of the hospital. After that, and this is another, I think, differentiator of us, we work with different kinds of solution providers. So if I take a look at some competitor products, a lot of them are really focused around their core products, like, for example, filtration. We are not bound to that. So we are working with a group of companies with different technologies, from filtration via UV treatment to bipolar ionization. And we have experience and data sets of when and in which kind of conditions we used what kind of solution. And therefore we can design and together with the end customer and with our partners, what is the most effective and most cost-efficient mitigation solution to a specific problem. So in this hospital, for example, what we did is we installed a bipolar ionization solution specifically in that chemical room to neutralize the VOCs and the other chemicals directly where they are created. That was the best strategy for this specific project. It might not be the best strategy for another hospital, because the problem might lay somewhere else or might lay within the ventilation system. So that's our approach. We are trying to define individually the best strategy for our customers, and then proving with our monitoring the actual effectiveness. And I think this is what we see here on the picture, the effectiveness of our solution after we have implemented the strategy. And I think that gives the end customer peace of mind. First of all, they know they can pinpoint where in their building they have a problem. And we define a strategy, we implement it, and we show the results through our continuous monitoring. And with these kind of experience, we have a wide range of portfolio solutions that we would recommend together with our partners, depending on what the specific problem for a customer is.
In terms of particulate monitors, how many particulate monitors could there be? Would you have them throughout a hospital, for instance, or?
Yeah.
And they're
so we work with.
Go ahead.
We work with multiple pollutant sensors. So all of our pollutants incorporate a standard set of sensor components in there. So what we always measure is temperature, humidity, CO2, very critical factor for demand-driven ventilation, and right now during COVID-19 for the dilution of indoor air, potentially contaminated indoor air with fresh air. The fourth one is PM 2.5 and PM 10, so particles in two different size classes. This is the main indicator to determine the filtration efficiency. And also right now during COVID-19, we know that an increased level of particles inside but also outside is increasing the mortality and also the risk of virus spread within the building. And then the fifth pollution is VOCs, and or also called total VOCs. So this is a group of different kinds of chemicals that gives you a very good indication on the chemical concentration in the air. So these are the 5 standard pollutants we always measure, and then we have different kinds of sensors where we can add different kinds of sensor modules if requested from the customer. But all of our indoor sensors we are installing in the space or within the air handling units, we also have sensors for those, are incorporating those 5 basic pollutants that we use and measure. And we can use those to to get insights in different kinds of things. For example, energy efficiency in terms of ventilation, but also health parameters like particles and chemical concentration.
And I think that another important aspect here is the ability to use the particulate as an indicator of how efficient your filtration system might be in removing viruses. Let's say, you know, in various parts of the building, you've got various, even though all the air is theoretically going through an HVAC filter, let's say MERV 13, but let's say you go to a HEPA filter, you know, those areas with that are well served by that filtered air are going to show lower particle levels, which means they've also, more of the virus has been removed. So as opposed to the relationship with outdoor air is certainly indirect, but important. But inside the hospital or inside a meatpacking plant or whatever, it would be direct. But because all that air has gone through an HVAC system, and if you've reduced the particles compared to the outside air by 80%, you've probably reduced the virus by you know, by 80%. So it seems to me that correlation is a very important one.
Yes,
Absolutely.
exactly. Sorry, Ellie, go ahead.
No, I just wanted to mention another factor that we usually measure and is an indicator of the level of fresh air in the building is the CO2 level. So if you have like, you know, 10 people in an enclosed area breathing the air and that is being recirculated but not having enough fresh air inside, you basically increasing the amount of air that's rebreathed again, you know, so you're inhaling the exhaled air from somebody else. And then the correlation between, you know, the CO2 level and how much fresh air is inside your building is basically can indicate that you have a higher chance of getting infected or not, especially in areas that are packed of people. Like for example in the production areas or in the office space, and you can actually adjust your ventilation and as well as the capacity of the room, how many people can be in there at the same time or not.
Yeah, that's certainly very very interesting. And in terms of assisting the customer longer term, are you doing remote monitoring and support, or just how does that take place?
Yes, so we are targeting a long-lasting relationship with our customers. So what we recently started doing is we are helping them on their journey to cleaner air with like providing them different kinds of progress indicators and progress scores throughout the monitoring period. So we constantly, one of the things we, for example, do every month, we would provide an overview report to our customers with the most up-to-date recommendations. And what was resonating recently very good is we are updating our COVID-19 recommendations from sources of like the CDC and ASHRAE on a regular basis. And we're providing this kind of info also to our customers. So we are providing more than only the sensors It's really an ongoing service on how we are interacting with our customers, and we try to continuously provide value and new value to them.
Yeah, that seems like it's really very important. What I wanted to do too was to get your comments here. We have these daily alerts, and what we had tried to do, here's the daily alert that. First of all, it starts out by relating three of the things we're involved in, which is the pharmaceutical solutions, the technology solutions, and then the health of the individuals. But what disturbed us was that the Staten Island Mall, talked about MERV 13 filters being the best there is, and putting some of these in, and they're basically going to solve all the problems. Well, they're a lot more efficient filters than MERV 13. And one of the things that seems that you would be able to do is, say, within a mall, to estimate how many people are entering that mall and how many of them are wearing N95 masks versus N30 masks, and what the efficiency of the filtration system is. And then there are all these calculations. With an N30, the transmitter's emitting, 70% of the particles are still going, 0.3 micron particles are still going out. And with a MERV 13, you're going to still have 21% afterwards, and even with 101 dilution and so forth, you've still got the recipient is going to get a significant amount. So all these things can be calculated here. We just took, the transmitter, 2 million virus particles, and basically he's getting 294 virus particles with these in a more or less efficient masks and things. But and then you go on, if you're wearing more efficient masks, N100 masks, obviously these things go way down. But from the purposes of what you're doing here, you're going to be able to map what we call either clockwise and counterclockwise motion of the air. If you go from the emitter through an HVAC system, it's got he's got a mask on, filter here, then you dilute it, then the recipient is getting a very diluted version of what was emitted. But if the airflow is counterclockwise here, in other words, it goes directly from the emitter to the recipient, then it's only whatever mask the two of them are wearing. There's no other protection, essentially. But it seems to me
Sorry. Didn't want to interrupt. Just wanted to mention a point here that might have have a misunderstanding from a lot of people, that when somebody is talking about using a MERV rating, for example MERV 13 for their air handling units or HVAC system, what they are doing, especially with the outside, 100% outside air, the only thing that they are doing is cleaning the outdoor air coming in, not the air that's recirculating inside, for example, or is inside. If you want to, if you have a pollution source that's generating by, people indoor or something from inside, either you need to put your air handling units in a recirculation mode and have a higher filtration, or you have to have like a portable filtration device sitting in that area, which is cleaning the air constantly. A combination of MERV 13 and 100% outdoor air ventilation only result in a clean air from outside coming in and diluting the air, not cleaning the virus completely or killing the virus or capturing the virus inside the area. This is something that needs to be clear for a lot of people, that they think that MERV 13 or like higher MERV rating in the air handling unit is capturing the virus. It is not, because the virus is not outside, it's actually inside the building. And as long as you're not passing that virus through a recirculation mode, through those filters or a portable device, that virus can still stay inside the building.
Yeah, I think you've.
And I think what you're sorry, Robert, what your model shows very good is that it's not like this one solution that will solve all our problems. As you said, we cannot say we upgraded to MERV 13, now we can safely reopen. I think that is not true. And your model and approach shows that, I think, very good. We have a lot of variables in that process. And as Ellie explained, a MERV 13 filter is useless if your ventilation system is not optimized to exchange more air really on the inside. A MERV 13 filter is useless if you're only filtering the outdoor air, because the assumption that in like the fresh outdoor air is probably the virus concentration is super low. So here you're not taking out any viruses, maybe some particles from the outdoor air. So I think we have to look at that very holistically, as you're doing it here in your approach, and I really like, because that's in the end also what we are trying to calculate. What is the virus concentration in the indoor space with all the variables that we know we have influence on? So fresh air rate, then recirculated and cleaned and filtered air on the inside by a recirculation unit or by a recirculation purifier, a retrofit device, or by, for example, bipolar ionization or UV treatment. So I think it's really important to start with like the building characteristics, how is your ventilation system designed, and then to work with the customer in defining what is the best solution that actually what the target always should be. The recipients should see the least amount of virus concentration in the indoor space. And to calculate that has a lot of inputs like dilution factors, central ventilation system, and again, it's also different throughout the building. So what we see a lot also when we do our projects is some spaces in your building are ventilated perfectly. Your particle count is super low because it sees a lot of air supply from the ventilation system with MERV 13 filtered air. On the other side, we have some rooms or some areas where maybe also more people are from time to time, where we have hotspots of like poor ventilation, where we then have to use retrofit purifiers, for example. So holistically looking at the topic, I think is the important message here.
Yeah, I think you bring up some good points, and certainly the differentiation of how much of the air is being recirculated, as you mentioned, measuring the CO2 in the air is therefore very critical as well. And then certainly measuring the velocity of the air, although I guess basically by measuring the CO2 and some of these things, you could probably, at various different places, you can get an idea of what your velocity flows and things are. But all of this becomes very critical. And it seems to me that there is a huge amount of opportunity, even in terms of taking into account crowd levels, and even as I pointed out, that I think one of the most important things is the people coming into the space. What efficiency masks are they wearing? Even if the average person, maybe only one in 1,000 is going to be a transmitter. If all 1,000 are wearing N95 masks, or if all 1,000 are wearing no masks, it's a huge difference. But again, getting back to the mall sort of a thing, if you can input into your equations the number of people in these spaces, then obviously that's another big variable, is it not?
Yep.
Absolutely.
Yeah,
and
absolutely. Occupancy tracking is definitely a big topic. So we are working with like rough indicators based on CO2 level. And we also partnered up with companies who have like dedicated solutions for occupancy tracking. So also here, qlAir is not this like one and only solution that fixes all the COVID-19 headaches, but we're really partnering up with different companies, and occupancy sensing is often a very important puzzle piece to have like put safe buildings as possible.
And I want to point out, I just want to point out, because your listeners most probably will will listen to this and it's like, oh my God, this is so complicated and over my head. And that's what our team or teams like us wants to do and help and make things as easy as possible. So become like a one-stop shop for all of these solutions. So they only have to look at one data point, one email, or one recommendation. So they don't have to go through this, okay, what is my system is doing? Am I doing it right? Is what filter? These will become our problem and our hassle, and we help them to have the peace of mind and run their building efficiently and much more safe and clean.
Yeah, that's a very good point. Humidity is another variable here. You mentioned the amount of outside air. If you're in the South in the summertime, it's very difficult to use outside air because of humidity and temperature. On the other hand, too, the humidity levels for the virus are optimal between certain, 40 or 60%, I forgot what their level is, and on either side of that, you're not optimum. So measuring the humidity in the space becomes critical for several different reasons. One is its effect on the virus life, but more importantly, just how much outdoor air can you recirculate.
Absolutely. You actually brought up a good point that I wanted to also talk about a little bit because you're right about the humidity level being important for the virus survival. Based on the literature, the virus survives, this type of virus, because they're lipid enveloped. They survive on a humidity below 30%. So the recommendation is to keep your humidity between 40%, 70%. And basically keep monitoring that for the level. One of the concerns that a lot of facility manager had regarding all these recommendations from 100% fresh air and putting higher class or higher MERV filter in your HVAC system, their biggest concern is the pressure that they're putting on their equipment and reducing the lifetime of the equipment itself. Their utility bill is going to skyrocket high. The life of the equipment is going to go low if they have to run it on 100% fresh air and also having tighter filter, higher class filter in that place. So by monitoring your space and looking at it, you'll see where is necessary to have this right solution. Where do you need to really have the outdoor ventilation, and where you're okay to have recirculating the air and not putting too much pressure and too much load on your HVAC system. So that's another value of looking at your at the critical areas and just have the mitigation systems for those areas and not for the areas that it's not necessary. You don't have to ventilate every corner of your building. You don't have to upgrade the filter in every single air handling unit of your building if you don't have too much crowd or traffic going in those areas. So this is something to keep in mind, that it is possible to optimize the operation of your HVAC system, being from upgrading the filter or scheduling the outdoor ventilation. It is possible to optimize that and run it very efficiently and make sure that you have a safe environment at the same time.
And so one of the opportunities for your customers in using your service is to not only achieve the levels of air quality that you want, but to do it at the lowest possible cost. Is that correct?
Absolutely, yes, yes.
You mentioned that you'd done this webinar. Is there a link on your site that we'd be able to lead viewers to that would have that information?
Sure, I can share with you the link later after the call.
Yeah, and we'll put that in the article and in the coverage of this interview. So I think that we've accomplished quite a bit. I believe that we really should have continuing discussions here. We're heavily involved in all this, particularly from the monitoring. We have whole services on monitoring. There's been a lot of breakthroughs. One thing we'll get into later too is that there are you certainly have the instrumentation that meets EPA requirements, but you've got a lot of instruments now for measuring a lot of these things that are very inexpensive and very accurate, even though they don't have EPA certification. And I would guess, you can incorporate very sophisticated monitoring techniques in these systems without generating a whole, impractically costly selection. So, and I think that the other thing is, on a holistic standpoint, taking some of these concepts and applying them to the citywide area with the filter cubes and some of these other things is probably, I would assume, something that you're heavily involved in as well. Is that correct?
Yes, Marcel can explain more about that because he's been in contact with the team. But that's what also we're working with the team.
Yeah, so I said it in the beginning already. Our vision from the beginning is we want to manage air like in a very holistic way. So outdoor air quality is a big topic for us. We are building out a platform with qlAir and our channel partners within Mann Hummel, but also outside, that really enables us to manage air in a holistic way within the building, outside the building, and for entire cities. And here, one of the next products we are about to add to our platform will be an indoor purifier that we're currently working on, that we then can connect to our air quality data and analytics and control those purifiers, again, based on real and live monitoring values or even prediction values. One of the other discussions we are also having is, after we have covered the complete indoor space plus the outdoor air quality information, also adding those filter cubes that are mainly designed to tackle air quality problems in hotspot areas of like cities, city centers, like neighborhood development projects, and to add those to the platform as well, so that in the end, the vision for Mann Hummel, I think, here is to have a holistic platform that covers all the important factors and controls all the important devices that have an impact on the air quality indoors, but also outdoors, for best protection of humans living in this area.
Well, it's all very, very interesting, and I've certainly been impressed. I know Alfred Weber and I were both speakers at one of the filtration conferences a number of years ago, and he was outlining some of these plans at the time, and it looks like his vision has certainly been enacted in a big way here. I know you've got a big research center in Asia and have a big commitment in this whole area, so I guess we're seeing the fruits of some of that.
Absolutely.
Yeah, well, I'd like to thank both of you for the interview today, and we'll send you a copy of it, and you feel free to use it in whatever way you might. We'll also look forward to getting a link to those to that webinar, and then make sure that our readers have access to that as well.
Perfect. Absolutely. Thank you.
I think what we can also do in addition is share our latest overview brochure with also the case studies.
Yes.
So, Robert, maybe there's another topic for another article or coverage in future. I think that might be interesting for you. It's five pages only, but it gives you a very good overview also of how we're working with the customer and what the customer value and end results really are that we are able to provide with our solutions.
Yeah, in fact, what we'd like to be doing, like just if we just type Mann in here, for instance, that we're really like to be covering what you're doing on a continuing basis. So we do have these alerts coming out every day, so we definitely want to be adding new material from you as we receive it. So we look forward to that as well.
Great.
Sure, I can email you both.
Sounds great. Look forward to working with you, and thanks again for the interview.
Thank you, and thank you for your time.
Okay, bye
Thank you,
now.
Robert.